Hi, welcome to ESP32 tutorial from Robojax. In this video we are going to build a 7-segment display counter using this ESP32 from SunFounder. We are going to build a counter from 0 to 9, then we will have a counter from 9 to 0. After that I'm going to show you how to turn on each segment, and then we are going to learn how to display A, B, C, D and E on the 7-segment display. ESP32 starter kit from SunFounder. This is the best ESP32 learning kit from SunFounder. It has this ESP32 microcontroller which has built-in Wi-Fi and Bluetooth. This board can do everything Arduino Uno can do or many other Arduinos can do, plus extra more features. Because we have Wi-Fi and Bluetooth, the possibilities are endless. You can get connected to the cloud or do the control or read information or values via your mobile device or your desktop or over the cloud from a far location. It comes with a camera extension kit where you can stream the video over Wi-Fi either through the cloud or to your network, and also it comes with micro SD card where you can save images on the micro SD card, or you can write from the device any information, log the information on the device and read it back. You can power the board using this included 18650 lithium battery, and it has built-in charger where you can connect micro USB and charge the battery. The kit comes with 320 pieces of component that you can learn tons of projects. Seven-segment display has a lot of usage in many devices that you see, that this kind of light, either white, green, blue even, and red, the different colors. This is 7-segment display, and 2, 3, 4 or maybe more numbers are used together to create with a 7-segment, create even letters or numbers. But this is just for numbers at the moment in this program. We're going to learn how to use it, and step by step everything will be explained. Here is the documentation page. If you come to SunFounder, under the Arduino, click on 2.5 7-segment display. Here it has explained everything, including what you need, all the components that is needed, and we have the schematic. The chip 74HC595 and 7-segment display with 1 resistor and 3 pins from the microcontroller from ESP32 is used. And the 7-segment displays explained here in terms of segments, and then wiring, actual wiring is shown. At the bottom we see how it works, this 7-segment display in terms of position. This is A, B, C, D, E, F. It goes like a circle, and then G is at the middle. And to turn each segment on, we are sending these values. To make 0, we need to turn, for example, all of this on except the middle one, so this will be 0. So, and here you can see it better. To, for example, this is 2, all these elements are on, only 2 is off. So this is the first one, and then second one, the third is off. And here you will see this is starting from this side, first and second is on, these 2 are on, then off, and then the 2 are on, then off, and then the 2 elements are on, this, and then off and on, off and on. So to display 2, we are sending this binary value, and if you like hexadecimal value, this is the hex value 0x5b. And the same with all other values, and to send this we are using this function called shift out, which is part of Arduino. For this lesson we need a 7-segment display. Remove the plastic, and then we need 220 ohm resistor and this 74HC595 shift register, and we are going to use breadboard and wires. For our wiring, first we create negative and positive on our breadboard. This blue line is used for negative, and all of these holes are now connected together. I have separate video about breadboard. The link will be below this video. And this is 3.3 volts. The same way, because the blue is on the other side, I hold it. Don't hold it like that. So our wiring will be the same. Blue is on the other side, and this blue is in here, and we will use it as a negative, and this red is for 3.3 volts. Connecting this red to one of the hole which is close to the red, and connect it to the red on this side. Get one black wire and connect it to the blue, and connect it somewhere on the blue on this side. Now we have common negative on that side, or ground, and also the same way on this side, and then 3.3 volts is connected to the other side. Our chip, I've already used it in previous lesson, so if I put it here, it will be just simply easy to insert. But if make sure to hold this notch here and the dot which shows pin 1 this way. So the hole as well, the notch and the dot. Push it, this. And then let's get our 7-segment display with a little space, not too far because our wires will be short. Just connected in here, and this is the top, and because the decimal point is on the lower right corner, not like that, like this, just insert it. Make sure to have enough room on this side for the wires and on this side, and insert it. So this is now ready. I'm clicking so show you. We will connect. Let's start from let's first start with that 220 ohm resistor. We have 5 pins. The middle pin, it will be connected to the resistor and to anywhere on the blue. If I connect it like that, it will be with a arc, but let me connect it flat so it will be safer. Like this. Connect this pin 1 from this chip. We'll start from pin 1, 2, 3. This is 1 up to 8, and then 9 to 16. So this is pin 1, and then up to 8, and then 9 to 16. Let's get, I don't have a brown wire, let's get the black. Pin 1, I'm inserting to pin 1 and connect it to the right top, as shown here. Pin 2, green, to pin 2 from the right. I'm getting green, connected to pin 2, 1, 2, and then to the 2 from the right, 1, 2, and in here. 3 is blue, connected to the second pin from the left. Let's get the blue. Pin 3, here, second pin from the left, connected, and pin 4, orange, to pin 1. I don't have orange, and here orange, pin 4, and then pin 1 of the from the left side. So this has been connected, and then we go pin 5, yellow, to the second pin from the left. Yellow, pin 5. You can connect it to any of these line. They are all the same. So second pin to the from the top, and that was, so pin 6 is purple, goes to the left top pin, which is pin 1. I'm going to use a red because we don't have pink. That is 6. I connected. Top left. So that is connected. Pin 7, gray. I'm going to use a black, which goes to the right first pin. Here, let's use 7. I'm using this black, goes to the right bottom, this wire. And then pin 8 goes directly to the ground at the top. So another black, pin 8. I can move it like that to the top, anywhere that you want. It is connected now. So this side, all the pins are done, and let's go to pin 9 is empty, pin 10 is connected to the positive, and the same way pin 1 is connected to the positive. So let's get pin 9, that's 8, let's go to 9 and to the positive, another positive, the last pin, pin 16, to the positive, so 3.3 volts. It is connected as shown here. And then this pin is the third pin from the left, so it's 15, 16, 14, that's pin 13 to the ground. Let's get a black. I'm going to get a blue pin, pin 13 here and to the ground. Pin 15 to the second pin from the right. Pin 15, orange, second to the right, and here. So all these are done. We need just these 3 wires to be connected to our board. This is 9, 10, 11. We get 1 wire to pin 11. Let's enter it. That's 9, 10, 11. That's pin 11. And then 12. I'm going to connect a white. That is 12. 13 was connected to the ground, and then 14. Another black. So that is 14. So we have these 3 pins already. Understand this better, let's here. Pin 11 goes to 26, and here from the right, this is pin 11. It goes to pin 26. We are holding it like that. USB is on this side. 26. Label. Then 12 goes to pin 27. The next one is 12. It goes to 27, which is beside it. And 25 goes to pin 14. So 14 is this one. It goes to pin 25. 25 is, they are in order, 25, 26, 27. Last one is to connect ground to the ground, and then positive to 3.3 volts, the last pin. Positive from anywhere from the red connected to 3.3 volts. This last pin is 3.3 volts. And get a black wire and connect it to the ground. And from the last second is the ground, connected like that. And the wiring is completed. Now let's open our project. Click on File, Open, and from the left side click on Download. Go to ESP32 Starter Kit Main. Double click on C folder, double click on codes, and then click on 2.5 7 segment, and then open the file that has this greenish color. Click open. So this is our file. From the top we are defining pin 27 as STCP pin, as we mentioned. For this chip, we have STC pin, SHC pin, and we have DS pin, these 3 pins. And we are defining them as an integer of constant, so they don't change. And also for this SHCP, pin 26, and then DS pin, pin 25, all as integer. And this is our array data. I pressed enter and brought them down. And I have added this comment so you can understand them easily. So this is printing 0 and this is printing 1. These are the values up to 9. And because this is array of type integer, we can call it in terms of index and read it. Inside the setup, we have these 3 line of code which will run only once, and we define this STC STCP pin as output using pen mode, and then STCP SHCP pin as output, and then the S pin as an output. Inside the loop, which runs from here up to here, this is another loop inside the main loop. So this is a for loop that goes from 0 up to less than 10, which is 9. So it goes from 0 to 9, and this variable num of type integer is incremented here, and from 0, and it becomes 1, 2, 3, up to 9. Now every time it changes, we run these codes. First, we set this STCP pin as low, and then we use this shift out pin, pass this DS pin and STCP pin, and most significant bit is taken first, and then we go to array, and then this num, when it is 0, it gets the first value, and then it becomes 1, 2, 3, and then every time it goes, it will send a value to the chip, and this one sends it to high, and the value is displayed on the screen. It's shifted, and then we have here 1000 millisecond if it is 1000, and delay so we can see the digit. Then it comes here back and increments it. It becomes 1. Num is 1, num is smaller than 10, 1 is smaller than 10, and it does all this, and it becomes 2, 3, 4, 5, 6, up to 10. When it becomes 10, it comes here, 10 is not smaller than 10, and exits, so we can run from 0 to 9, and we will print these values. This is hexadecimal value, as I explained it. This is hexadecimal, and this is binary. The binary could be sent. If you want to change it, you could do so. You can put binary here, but instead of 0x, just put capital B, and it will be considered as a binary value. Now let's see how we can select the ESP32 board. We can click here under the select board and type here ESP32 DEV. As soon as you type dev, you will see dev board. You can select it and click OK. So the board has been selected. Now we have to select the port. The other way to select the board is click on Tools, Board, ESP32, and select the ESP32 dev module. Now we have to select the port. If I click here, it shows 2 ports, and I don't know which one belongs to my device. Sometimes you will not see the number properly. So the best way to be sure, right click on the Start menu, go to the Device Manager, and you will see here the ports. If I click on this arrow, it will show me the ports. One is USB serial CH340, the other is USB serial device. And here, now it's connected. If I disconnect this, one of them disappears. The one that disappeared is my board. So 6 stays and 8 disappeared. If I connect it, so 8 is my COM port, CH340. Now 8 is my COM port, and I can select it. Or I can click on Tool, Port, and here you will see it. You can select whichever you want. Ours is COM8. Now we have successfully selected the board and the port. And this is very important. It must be done first. And here, after the code is uploaded, we are getting the counter, and it's working. And if you want to speed it up, let's say make it 500, so this will go faster. I'm uploading the code with 500 millisecond delay. So it got faster. Let's make it 200. Even faster. Now the code is uploaded and it goes way fast. And now let's see how we can turn on only for one digit and how we do it without that for loop. So in here, inside the for loop that was here, I removed it. So we use these 3 lines and here array, and then put the number that you want. Here, if you want 0, just put 0. Oh. And I just changed this to 0, and let's see. When the code is uploaded, we are getting 0, and the same way, if you want 3, let's upload it. This will be 3. You see, this works. We don't have to define in terms of binary or anything, because from 1 to 9 is already here, so we don't have to worry. Just mention the digit, and that digit will be pulled up from 0 to 9. And now we are going to learn how to make this counter. As you can see, 0, 1, 2, 3, it goes up to 9, and then waits 1 second, and it goes back 8, 7, 5, 6, 4, 5, 4, 3, 2, 1, and up and down, up and down. So this is a different counter. And here is the code. We had this loop. I've just copied it with 1000 millisecond delay, and I pasted it here. But instead of starting with num to 0 and incrementing and this, now I've defined it as num to equal 9. It starts from 9. As long as the num is greater or equal than 0, we will decrement, and the rest is exactly the same. So this goes from 9 to 0, and the loop comes back. Here it goes from 0 to 9. Less than 10 means 9. And when it finishes, comes here 1 second delay and continues. And this is now with 300 milliseconds. And here now we are going to learn how to turn on each segment separately, so you can understand, and in the future for any purpose you can use them. Here I've created these data. B means binary, and each segment starts with A, B, C, D, E, F, G up to here, and then the last one is empty because this has 8 and we have 7 segments. So B is 1 letter here, A is on, and then everything is off, and then here B is on, 1 means on, and then C, as you can see, it's like a ladder up to here, and then for 8 we turn everything on, all the 7 segments, so this will be like 8. And the loop is exactly the same. Here we put 8, which means it goes from 0 to 7. And here the code is running. As you can see, I can decrease it by 300 milliseconds, and let's make this run faster. So now the code is being uploaded. A, B, C, D, E, F, and all segments. So it goes one by one up to and here let's display some alphabet. As you can see, A, and then B, C, D, E, F. So we can do this with 7-segment display, but not other letters, because there might be some confusion. And this can be used with hexadecimal as well. And now let's see how we can create a letter A. For this to be turned on as A, we will turn on everything like that except the 1, first, second, third, fourth. The fourth one should be 0 and the rest should be all 1. So we can send that directly to the module. So I removed the loop and everything, and here we can send the fourth one should be 0, correct? I said, so the first one is 0, and then we have 8, so that is 3, 4, that's 5, 6, 7, 8, so total is 8, 1, 2, 3, the fourth one we said should be 0, and then we have 3 on this side, 3 on that side. Let's check it again. So we have 1, 2, 3 is on, so 1, 2, 3, and then 1, 2, and then this one is 3. So yeah, that's correct. Now if we upload this code, you will see that we should get A unless I made some kind of mistake. Let's upload it. B means binary, so we can send the value directly in here. This B means binary. So let's see. Correct, so I have created A. And if you want to create B, then everything should be 1. That's easy. I'm just changing this to 1. So it looks like 8, and also it looks like B if you want to use it. And here is the code for A. We have everything on. If I display it here, in order to display A, everything should be on except this piece. So D is off, and then we can display A. As you can see, just D is off. And the same way for B, this is a lowercase b, then we have these 3 on, and A and B should be off. So A and B is off, the rest everything is on, and the rest of the code is exactly the same. We are just running a loop to display it. If you pay attention now, this is running one by one. When it's 8, it's very dim. The reason for that is using of one resistor. In proper design, each segment should have its own resistor. Remember, one resistor is for one segment, but when you turn everything on, it's dim because a lot of voltage is being dropped across this resistor, and as a result, these segments will be dimmer. So proper design will require to have resistor for each segment. We have resistor here. I have separate video on this where we drive it without this chip, just Arduino. The link will be below the video. So this will be this will have proper light intensity consistent. Any digit will have the same intensity.